10.3 Geographic regions at risk for cyclones. Here is a map from FEMA, the Federal Emergency Management Agency. It shows the frequency of hurricane and tropical storm activity by county from about 1851 to 2012, though data in the Pacific spans only 1949 to 2012. The dark green-gray color denotes 65 to 141 hurricanes over this time period. The greenish color represents 29 to 64 hurricanes over this time period. The tan color represents 1 to 28 hurricanes, and the white, no hurricanes over this time period. Idaho is all white. So, where is the greatest risk for hurricanes? Interestingly, the southeast and Gulf coastal areas experience on average about 5 hurricanes a year. Are there any places along the coast not at risk or at an extremely low risk for hurricanes and tropical storms? Why? Let me give you a hint as to why. It has to do with the surface water temperature of the ocean. So I bet it doesn't surprise you that though hurricane season in the northern hemisphere spans from June 1st to November 30th, most hurricanes occur between August and September. They're hotter. Here's the map showing tracks and intensity of all tropical storms. We've seen it before. It shows areas of risk for the whole world. Again, note that though we are often more concerned about domestic tropical storms, the Western Pacific has about 3 times more tropical storms as compared to the Atlantic. In North America, the geographic region at risk from extratropical cyclones is far larger than from tropical cyclones. Severe weather from extratropical cyclones is greatest in the interior of the continent, but may also occur in coastal areas. The greatest threat for the severe weather varies with location and time of year. In winter months, extratropical cyclones create strong windstorms along the Pacific coast and nor'easters in the Atlantic coast, as well as produce heavy snowstorms and blizzards, especially in the Sierra Nevada mountains and within and east of the Rocky Mountains. During spring and summer months, extratropical cyclones are responsible for the severe thunderstorm and tornado hazard in much of the United States and Canada east of the Rocky Mountains. Extratropical storms can produce severe weather. So here's a map from NOAA, the National Oceanic and Atmospheric Administration, showing severe weather days per year from 2003 to 2012. With days with at least one tornado, wind, and/or hail report within about 25 miles. Severe wind for this map is defined as 50 knots or greater, which translates to 57.5 miles per hour. And reports were corroborated with downed trees, which biases the wind data to areas with trees. So the Great Plains and Midwest areas might be shafted on getting credit for severe wind due to lack of trees. But I still think the map gives us a good idea of areas with elevated risk from the extratropical cyclone hazard. So on to what the colors mean. White is less than 5 severe weather days from 2003 to 2012. Light yellow is 5 to 10 severe weather days. Dark yellow is 10 to 20 severe weather days. Orange is 20 to 30, and dark orange is 30 to 40. There are not locations on the map over 40 severe weather days, though western North Carolina reaches 40. What patterns do you see? I see that here in the West we are pretty low on the number of severe weather days as compared to the Plains states and the eastern states, though the West still does get severe storms. Risk from extratropical cyclones is greatest in the interior of the continent, causing increased risk of tornadoes in those areas. Remember Tornado Alley? However, coastal areas are still hit with extratropical cyclones. For example, nor'easters hit the east coast, and the Pineapple Express hits the west coast. 10.4 Effects of cyclones. There can be lots of damages and loss of life associated with cyclones. Effects include flooding, thunderstorms, tornadoes, storm surges along shorelines, and heavy rains. Extratropical cyclones can also produce severe snowstorms and blizzards at low temperatures. We will discuss in more detail storm surges, high winds, and heavy rains. Storm surges cause the greatest damage and about 90% of all fatalities for tropical cyclones. They are a gradual rise in the water level along shorelines. If the water remained fairly still, there would just be flooding. But of course, the winds are strong and fast, causing waves that in turn cause most of the damage. The image is a before and after image of the Louisiana coast. The devastation was not caused by one factor alone, but by a combination of storm surge, high winds, and heavy rains. Storm surges are due to several factors. 1. Water is pushed by winds onto shore. The larger the area over which the wind blows, i.e. larger fetch, the higher the water will rise. In the Atlantic, the strongest wind and highest surge is usually on the right forward quadrant of the hurricane. 2. Water will rise due to the low pressure core. A drop in 1 millibar pressure corresponds to a water rise of 1 centimeter, which generally contributes about 1 meter water rise. 3. Water will rise due to shallower ocean depths. And 4. Water will rise due to coastline geometry. For instance, a narrowing inlet of water can funnel waves into the coastline. Also, in a partially enclosed body of water, say a lagoon, resonance can occur as waves bounce off the shorelines, crossing the lagoon several times. This can result in wave amplification. Often a storm surge causes a rise in water about 10 feet higher than at high tide, but can be greater than 40 feet. Obviously, the storm surge is higher if the hurricane and high tide coincide. The picture is a before and after picture of New Orleans when Hurricane Katrina hit. Of course, much of this flooding is associated with dike failure, combined with storm surge and heavy rains. Another result of flooding from the storm surge is that storm waves and currents erode beaches, islands, roads, foundations, pretty much anything in its way. Here's a couple of erosion terms for you. Overwash is the landward migration of eroded sediments, and the resulting washover channels can drastically alter islands or peninsulas. However, these washover channels are usually naturally filled in and repaired as the currents and sediment supply return to normal. The image on the right is of 2011 Hurricane Irene overwash, with sand swept back from the beach. And the images below are before and after images of the coastline as affected by Tropical Cyclone Sandy. Notice the washover channels on the beach. High winds also cause a lot of damage. The strongest winds are in the eyewall and northwest quadrant of the storm. That's the same as the right front quadrant. The highest hurricane wind records are 190 miles per hour for sustained winds and 200 miles per hour for gusts. The highest extratropical wind records are 231 miles per hour gusts. At this wind speed, destruction is total. You can refer to the Saffir-Simpson scale for some wind destruction descriptions. The image is of the Florida East Coast Railway Overseas Railroad relief train derailed due to wind in Florida during the 1935 Labor Day hurricane. Shows what 200-mile-per-hour gusts can do. Heavy rains are also an effect of cyclones. Remember that in some extratropical cyclones, the heavy precipitation is actually snow or ice. An average hurricane produces 1 trillion gallons of rainwater each day. That's a lot. The highest tropical cyclone record rainfall is 45 inches in 12 hours. Remember, in Idaho, we get about 16 inches per year. Less intense cyclones still produce lots of precipitation. Sometimes they produce so much precipitation in a given area simply because they are not moving very fast. Inland flooding, as opposed to storm surge flooding, is affected by several factors. The picture below is some flooding associated with Tropical Storm Sandy. What do you think the several factors that affect flooding are? Take a moment of pause and think back to previous chapters, such as the flooding chapter. What increases flooding? These are 4 factors particularly associated with cyclone storms that increase flooding. 1. The speed of the storm can increase flooding if it is not moving very fast. Just mostly staying put and dumping rain in one area for a longer period of time definitely increases the associated flooding. 2. Land elevation changes as in increasing elevation, and temperature changes as in decreasing temperatures can also increase precipitation by increasing storm condensation and intensity from the additional latent heat. And the resulting precipitation will also increase. 3. Interaction with other weather systems, such as a hurricane joining forces with a developed or developing extratropical cyclone, would also increase precipitation and flooding. Double whammy. And 4. Original soil moisture content and lake and stream levels will affect flooding. Can the area absorb any more water? Was it about to flood before the storm hit? If it was about to flood before, then it will flood even more after the storm hits. Did you think of more ways a storm could increase flooding? Another way is downstream flooding by the coast a few days after the storm hits, as inland precipitation makes its way back to the ocean. The shoreline gets 2 flooding events. Lucky them! Downstream flooding and storm surge flooding. There are lots of ways to cause flooding, and these large cyclonic storms with intense precipitation are great at it. 10.5. Linkages between cyclones and other natural hazards. Flooding, of course, also coastal erosion, mass wasting, tornadoes, thunderstorms, snowstorms, blizzards, and climate change. The images to the right are before Hurricane Ike and after. What linkages between the hurricane and other natural hazards can you see in the picture? The 2 obvious ones I can see are flooding and coastal erosion. Can you think of any more? How might mass wasting be linked to cyclones? What is the link to climate change? Think about it and see if you can come up with some reasonable answers. If you'd like to double check your reasoning, go ahead and email me.